Welcome to my channel once again. I'm your boy, Dr. Nchebe-jah. Today I'm discussing biochemistry. So I need you to pay more than usual attention to this discourse. And mind you, this does not substitute for your lectures, does not substitute for your textbooks. All right, this is just a recap and discussing some of these questions. Most of the questions will be discussed at the end, but majority of them also will be discussed in the middle of this discourse. So I want you to take your pen and paper and pay attention. Let's start with this. Do you know the functions of protein? Okay, let me give you this question. Proteins perform all of the following functions except A. Catalyze metabolic reactions, give structural strength to cells and tissues, produce muscular and other forms of movement, regulate transport of solutes into and out of the cell, store hereditary information. Which one is not a function of protein? Put the answer in the comment section below. A drastic conformational change in a protein in response to extreme heat or pH is called what? Is it deconformation? Is it sedimentation? Is it saturation? Is it denaturation? Or is it contamination? You put your answer in the comment section below. Dash reaction breaks a dash into its monomers. Dash reaction breaks a dash into its monomers. Hydrolysis, polymer. Dehydration synthesis, molecule. Dehydration synthesis, polymer. Polymer, molecule. Condensation and reactant. What is your answer? You can go back and listen again to these options. I want you to put it in the comment section below. Dash differ from one another in their number of neutrons and atomic mass. Is it isomers? Is it cations? Is it anions? Is it isotopes? Is it electrolytes? Is it free radicals? Put this question and then put the answer in the comment section below. All right. What kind of bond attracts one water molecule to another water molecule? Which kind of bond is that? Remember, one water molecule is H2O, right? So the oxygen is bonded at two different sides by hydrogen. So that oxygen to hydrogen bond, which bond is that? Now, if that water molecule bonds with another H2O, all right, meaning that the oxygen in one is bonding to the hydrogen in another water molecule, what kind of bond is that? So the question can be asked in two different forms. Like this question is saying, what type of bond attracts one water molecule to another? They can still ask you, what kind of bond is in one water molecule? Two different types. They can give you an ionic bond, a peptide bond, a hydrogen bond, a covalent bond, a hydrolytic bond. Are you able to differentiate between a covalent, an ionic, a peptide, a hydrolytic, or even a hydrogen bond? Do you know where they are found in nature? Finally, for this introduction, sodium has an atomic number of 11, right? Let's assume it reacts with chlorine, and chlorine has an atomic number of 17 to become stable. In the reaction, sodium will dash, while chlorine will dash. I want you to attempt this without options. Okay, I'll give you options. Sodium will accept one electron, chlorine will give up one electron. Sodium will give up one electron, chlorine will accept one proton. Sodium will share one electron with chlorine, chlorine will share one electron with sodium. Sodium will become an anion, chlorine will become a cation. Sodium will give up one electron, chlorine will accept one electron. What is your answer? I'll tell you at the end of this discourse. So let's dive into this discourse properly, right? As a form of introduction, I need you to understand that biochemistry is all about, studying the molecules that make up life, all right? Carbohydrates, fats, proteins, and nucleic acids. These are the major molecules that make up life, all right? Very important for you to know this. And discussing their physiology, nutrition, health, all these things are biochemistry. Very important for you to know. Now, in the periodic table, everything is around, elements are arranged by atomic number. Atomic number is the number of proton. What is an element, by the way? An element is the simplest form of matter to have unique chemical properties, all right? It can be broken down to another substance by ordinary chemical means. Simplest form of matter to have unique chemical properties. We have about 24 elements that has anything to do with biology. 24 elements, all right? We have these 24 elements are divided into major elements, lesser elements, and trace elements. Major elements like oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. You need to learn these things. Like trace elements like the chromium, cobalt, copper, fluorine, iodine, and manganese. Also important for you to know. And when we are discussing about a compound is a substance that consists of two or more different elements in a fixed ratio. We already know what an element is, all right? Now, a compound is when you bring two elements in a fixed ratio and combine them together. An example is what? An example is sodium chloride. So that leads us to the atomic number and the mass number, all right? Now, the atomic number is the number of the number of protons in an atom. That's atomic number, protons. Why mass number is number of protons and neutrons. Like using sodium as an example, as you can see it here, using sodium as an example, the atomic number of sodium is 11. Why? Because sodium has 11 protons. Why the mass number is 23? Why? Because sodium has about 11 protons and 12 neutrons. So if they tell you the atomic mass of proton is 23, and they ask you to find neutrons, what do? You just minus the 23 from 11 because you already know the proton, and you know that atomic mass is the atomic mass is the same thing as the mass number, all right, which is the sum of the number of protons and the number of neutrons in a nucleus. Make sense? So as you are seeing on the picture, atomic mass here is protons plus neutrons, that's 23. All right. Why atomic number is 11? Because it's number of proton, meaning that if you remove 11 from 23, you get number of what? Neutrons, which is 12. So you should also know that protons are positively charged, electrons are negatively charged, and neutrons are what? Electrically neutral. Now, when you are talking about the behavior, all right, the chemical behavior of these elements, right, it's all about electron. Just know it's all about electron. You understand? These valence electron are what determines how a particular element behaves. All right, how atoms share, steal, or donate these negatively charged particles to achieve stability. Right? So the nucleus is just there. The neutrons are in the nucleus. But the electrons, are the outside, flying up and down, just like a butterfly. All right? Very, very important for you to know this. Now, if you take sodium chloride for an example, the atomic number of sodium is 11, for chlorine is 17. What does it tell you? It tells you that sodium loses one electron and become what? Sodium plus. While chlorine accepts that electron that sodium lost and become what? Chlorine negative. So that's how two charges attract each other, or like charges attract. Sodium is already a plus, chlorine is a minus. The two of them attract each other to form what? Sodium chloride. So sodium loses one electron. Chlorine what? Accepts one electron. Can you remember that question I asked you from the outset? This should be the answer. Now, how about if they ask you a question on oxygen? All right, the atomic number of oxygen is 8. The atomic mass is 16. What does it tell you? They are asking you about the valence electron. Just look at oxygen here. For example, this part is it's not included. That's the nucleus. So this is the first shell. The first shell will be filled by 2 valence electrons. That's 1, 2. The next shell will be filled by it's supposed to be filled by 8. But what do we have left? We have 6 left. So 1, 2, 3, 4, 5, 6. So when they're asking you about the valence electron for oxygen, you are talking about what? 6 electrons. So 2 electrons in the innermost shell, 6 electrons were in outermost shell. That one in the outermost shell is what we call what? The valence electron. So meaning that oxygen will take 2 electrons, you understand, to become what? Stable. That's why you see H2O, all right? You see an oxygen, it needs 2 electrons, 1 hydrogen, 1 hydrogen. All right, the hydrogen is 1, the other hydrogen is 1. So it takes the 2 of them and combines with the 2 of them to form what? Water, H2O. Now, when we are talking about the bonds, all right, when we are talking about the bonds, this is oxygen, this is hydrogen, this is hydrogen. So there's a bond here, there's a bond here, all right? So this is oxygen sharing, I just mentioned this in the last slide, oxygen sharing 1 bond with this hydrogen, oxygen sharing 1 with this hydrogen. This sharing is known as what? Covalent bond. Covalent bond. And are they equal? Yes. So it is what? Non-polar covalent bond. If the sharing is not equal, it becomes what? Polar covalent bond. So I need you to understand the difference between polar covalent bond and what? Non-polar covalent bond. Make sense? Now, assuming this is 1 water molecule, this is another water molecule. They want to combine with each other. So this oxygen here is combining with this hydrogen here. Will it still be covalent, non-polar covalent bond? No. It will no longer be covalent. It will be what? Hydrogen bond. So when hydrogen is bonding of 1 water molecule, is bonding with oxygen of another water molecule, it's known as what? Hydrogen bond. But when hydrogen of this water molecule is bonding with oxygen of the same water molecule, it is known as what? Non-polar covalent bond. I hope that sinks in. If you've not subscribed, please subscribe. Please. And if you've not liked this video, please click like. All right. Another thing I forgot to mention is how water molecule dissolves sodium chloride. All right. Now there's something we call ionic crystal dissolution. All right. So when ionic bonds between sodium and chlorine are broken by water, when you put sodium and chlorine inside water, the ionic bonds are what? Broken. So water molecule will surround the sodium and chlorine and separate them apart. So what you need to understand is that there is no bond, no new bond or whatever is formed in that solution. All right? It's just dissolution, ionic bonding. dissolving of that ionic bonding. Extremely important. We'll see a question with respect to this. Now, in terms of bonding, there are something we call molecular matchmakers. Right? All this dating app. This is the dating app for biochemistry. What is that? Valence electrons. So valence electron determines everything. Electrons in the outermost shell determines how atoms will interact and form relationship. So this is an outermost shell. You see, these electrons will determine how atoms will do what? Interact. They also decide bonding. They decide whether atoms will share, steal, or donate to achieve stability. All right. So all chemical properties, they stem from electron arrangement and interaction. So whenever you are asked any question concerning that, always remember outermost shell electron, valence electron. So this is what I was trying to describe initially. This is one water molecule. This is another water molecule. This is another water molecule. Did you notice something? Oxygen and hydrogen in this particular water molecule is bonded by what? Non-polar covalent, right? Look at it, non-polar covalent, oxygen and hydrogen, because they are sharing equally, right? But this is oxygen of another molecule bonding with hydrogen of another molecule. Oxygen of this molecule bonding with hydrogen of this molecule. Which bond is this? This is hydrogen bond. So you need to understand the question properly before you answer, because this question can be covalent bond or hydrogen bond, depending on if it is the same molecule or different molecule. So if the question is telling you the same molecule, it's a covalent bond, non-polar covalent. If it's telling you different molecules, it is what? Hydrogen bond. And another thing you need to know, it is because of this bond between oxygen and hydrogen, this adhesive bond, all right, that causes what? This that causes surface tension. Very, very important for you to know. It causes surface tension, and also it's excellent for as a solvent. That's why water is a universal what? Solvent. So you need to understand that it's because of the hydrogen bonding and also because of the covalent bonding. That's why all these things happen. Now, what is isotope? What you need to understand is that despite the fact that all atoms of an element have the same atomic number, but they differ in what? Mass number. All right? So that difference is what leads to isotopy. Isotopes. So isotopes of an element have the same number of protons but different number of what? Neutrons. The same number of protons but different number of what? Neutrons. Very, very important. And sometimes these isotopes can be radioactive. What do I mean radioactive? Sometimes those isotopes, their nucleus decays spontaneously, and when it decays spontaneously, it just gives out particles and energy. So any of them that decays spontaneously is called what? Radioactive isotope. Now, if you look at this very well, what do we have here? We have carbon. You see, this is carbon 12, carbon 13, carbon 14. Carbon 12 have 6 protons and 6 neutrons, right? Carbon 13 have 6 protons and what? 7 neutrons. Carbon 14 has 6 protons and what? 8 neutrons. Remember, the number of protons is equal to the number of electrons. So the only difference is what? Neutrons. Extremely important that you know this. The only difference is number of, this is neutron, this is neutron, this is neutron. The only difference is number of neutrons. So when you're talking about isotope, you're talking about elements that have what? Different mass, right? Just like siblings that share the same family. Their protons are the same family, right? Remember, protons, same family, same electron element identity, right? But different neutrons, that's different weight, atomic mass. So the same atomic number, different atomic mass. They are always very identical in their chemical properties, but they are different. Now, we have cohesiveness and we have adhesion. Cohesion and adhesion. When you're talking about cohesion, water molecules sticking together, all right, using their hydrogen bond is known as what? Cohesion. Sticking together using their hydrogen bond is known as cohesion. This cohesion leads to surface tension, capillary action, water droplet formation, splashing. All right. So when they're asking you a question, maybe they say somebody jumps into the water. All right. That tension, immediately when you jump into that water, is known as what? Surface tension. And that surface tension is caused by what? Hydrogen bonding to each other. They are bonding to each other. Now, when we are talking about fats, there's a reason fat avoids water, all right? And the reason is because fats, they are usually what? Hydrophobic. Hydrophobic, they fear water, they hate water. Make sense? Now, why do they avoid water? Because they cannot form, they are usually non-polar, right? So they can't form hydrogen bonds with water. That's just the reason. So because of that, oil and water, they separate, all right? So fat molecules, they cluster together for protection. They protect themselves against water. And this is very, very important because fat is what forms the cell membrane. If you've not seen my video on cell, please run now to watch that video, because we mentioned that the cell membrane is made up of about 98% fat, and that 98% 75% of it is what? Phospholipids. Extremely important. Also, I need you to understand that molecules are chemical particles that are composed of two or more atoms united by a what? A chemical bond. And compounds are molecules composed of two or more different elements. Now, we have something we call molecular formula and structural formula. What is the difference? Molecular formula identifies constituent elements and how each atom, all right, presents itself. That's what molecular formula is about. While structural formula identifies location. So location is structural formula. But molecule is the constituents. And this leads to isomerism, because this question always comes out. I don't know why it's not on my PowerPoint, but it's okay that I mentioned this information. So isomers are molecules with identical molecular formula, but different structural formula. Same molecular formula, different structural formula, meaning same constituents, but different arrangements. It's as simple as that. I'll give you just one example. When you're talking about ethanol and ethyl ether, for example, both of them, they have the same molecular formula, C2H6O, C2H6O. That's the same thing, same molecular formula. But when you want to present them in terms of their structural formula, what do you have? You have CH2CH2OH, CH2CH2OH for ethanol. That's the structural formula. But ethyl ether is CH3O, CH3. You see? Different structural formula, meaning that they have different arrangements. But in terms of their constituent elements, they are the same thing, C2H6O. So that's isomers. You need to understand this very well. Now let's discuss fluids, all right? We have mixtures. Mixtures are physically blended, but not chemically combined, all right? You need to know that. And, before we continue, we've already discussed adhesion and cohesion, right? I want to talk a little about thermal stability. There's something we call heat capacity, all right? Heat capacity is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree centigrade. So if I bring this substance, for example, this, and I remove 1 gram of it, I measure it, put it in Bunsen burner, start heating it from 0 degree centigrade to 1 degree centigrade, all right? The amount of heat I use to move it from 0 to 1 is what we call heat capacity. So heat capacity is not the amount of heat I used to move this substance from 0 to 1, no. But the amount of heat I used to move 1 gram of heat from 0 to 1. I believe you understand this. So let's talk about these chemical properties of talking about solution, colloid suspension. I want us to be able to compare the three of them. An example of solution is sodium chloride. An example of colloid is protein. An example of suspension is cells. All right. Now let's describe their characteristics, because if you know their characteristics, you'll be able to identify the questions in exam. All right. The major characteristic for solution is that they dissolve completely into individual ions. All right. That's solution. They dissolve completely. Extremely important. So solutions usually consist of particles called solutes mixed with a more abundant substance called solvents. All right. So solutes can be gas, solid, or liquid. Now these are the characteristics of solution that you need to understand. 1. Solution is defined by their solute particles. Solute particles must be under 1 nm, 1 nanometer. Solute particles do not scatter light, so light passes through them normally. Then the solute particles will pass through most membranes. Then they will not separate on standing. When you keep them, they don't separate. That's for solution. When you're talking about colloid, all right, which we mentioned proteins, their physical properties includes their particles that ranges from 1 to 100. 1 to 100. Remember, when we talked about solution, we said that solution, the particle is what? Under 1 nanometer. So when the particle increases from 1 nanometer to 100, or in between, or anywhere it falls along the line, it is what? No longer solution. It is what? Colloid. Bear in mind that. Also, colloid scatters light, and they are very cloudy. Particles, they are usually too large to pass through permeable membrane. That's why proteins don't pass through permeable membrane. If they do pass, they drag water with it. That's how we usually have edema. All right? Then particles remain permanently mixed with solvents when the mixture stands. When you're talking about suspension, their particles usually exceed 100. Colloid, 1 to 100. Solution, less than 100. Right? Suspension, particles exceed 100. Particles are too large to penetrate semi-permeable membrane, selectively permeable membrane. They are usually cloudy or opaque in appearance. They separate while standing. How about colloids? Colloids, do they separate while standing? I mentioned initially that particles remain permanently mixed with the solvent when mixture stands. So even if it stands, it remains mixed. But when you are talking about suspension, immediately you stand it, they separate. An example of suspension, you talk about blood cells. suspended in plasma. Very important for you to understand. Also, you can talk about emulsion. Emulsion are usually suspension of one liquid in another. So when you bring two suspension, you take this one and put inside this one, it becomes what? Emulsion. For example, fat in breast milk is an emulsion. Fat in breast milk is an emulsion. In case of if they ask you, for example. So that's why if you look at this diagram, this is a solution. You see how mixed it is. This is suspension, all right? But this is colloid. So when you're talking about molarity, R-I-T-Y, all right? You're talking about the known number of molecules per volume. Known number of molecules per volume. So if you see the one with rity, that's molarity, you are talking about volume. But if you see the one with molality, you are talking about weight, usually in kg, solutes in kg. But molarity is solute in what? Liters. Also, you need to understand what pH is, because pH determines acids and bases, all right? So pH is measurement of molarity of hydrogen ion on a logarithmic scale. Very, very important for you to know. The measurement of molarity of hydrogen on a logarithmic scale. So pH talks about what? Hydrogen, all right? Hydrogen. So if I say that the hydrogen of a certain solution is high, that means it is what? Acidic. If I say that the hydrogen is low, it is what? Basic. All right? And it works opposite in pH. Very, very important. So when the pH is low, it means it's very, very high hydrogen, meaning it is acidic. All right? So for example, there are a lot of food substances that we can classify based on their pH. A lot of them. You know, this is just few of them here that I have here. Like lemon juice is the most acidic compared to red wine, more acidic compared to tomato juice, more acidic compared to saliva, more acidic compared to ammonia. All right? Now, before we even talk about the buffers, let's talk about energy. Energy is capacity to do work. We have potential energy, which can be chemical energy or free energy. All right? I need you to read that up. Also, we have chemical reactions. And chemical reactions is a process by which a covalent or ionic bond is formed or broken. All right. Now we have chemical equations. That is symbolization of the cause of chemical reaction. Reactants to the left, products to the right. Extremely important. And classes of chemical reaction talk about decomposition reaction, talk about synthesis reaction, talk about exchange reaction. Very important for you to know. Decomposition reaction is usually when large molecule breaks down into two or more smaller molecules, like AB to AA and plus B. All right. Synthesis is building up. All right. Usually as a result of dehydration. Then we have exchange reaction. This reaction, the two reactants, they exchange each other to give a product. All right, like the stomach acid and sodium bicarbonate combining in the pancreas to form sodium chloride and H2CO3. This is an exchange reaction. So the beautiful thing about chemical buffers is that chemical buffers, they really help to, you know, make the pH, to resist changes in pH. We want stable pH in the body. All right, so they, you know, they are molecular bouncers. They resist that changes. So more like molecular pacemakers, if I have to say that, like an SA node of the heart that helps to keep the heart pumping. So that's how buffers does. All right, because when you do exercise, for example, you produce lactate. That's why you get tired easily in your joints. All right, so buffers immediately neutralize the excess hydrogen, keeping the blood pH to be stable, thereby preventing dangerous acidosis. Without buffers, exercise would quickly kill someone. It would become life-threatening because you produce a lot of acid. All right, so that is buffer. So both in the lungs, in the kidney, or the buffer helps to stabilize, to remove hydrogen, all right, or to put hydrogen. If you are tilting towards alkalinity, right, it will put hydrogen and make you balanced. If you are tilting towards acidity, that means your hydrogen is too much. What will you do? It will remove what? Hydrogen. That's what buffers does. That's what buffers does. So you need to bear this in mind. So buffer, you know, it's just a chemical bodyguard, you know, it maintains pH changes. This is just a summary. All right, when there's an excess acid, buffer will absorb the acid. When there's excess base, buffer will absorb the extra OH and give hydrogen. When it is stable, everything is happy. Everybody is happy. So they are usually the unsung heroes of biochemistry because they prevent you from having dangerous pH swings that could, you know, denature your protein, because pH denatures protein. And when protein is denatured, cellular activities will be, you know, inhibited or disrupted, and that can lead to death. It becomes pathological. Remember, all what we are discussing is what? Physiology. What is physiology? Function, function, function. Normal functions, not abnormal function. Most importantly, I want you to subscribe to this video. Please go now and subscribe to the channel. Like this video. Make comments. You must have made comments before now. All right? Please. If you don't know what to say, type my name on the comment section. So before we even talk about redox, remember what metabolism is. It's all chemical reactions of the body. We have catabolism, we have anabolism. Catabolism is breaking down, right, to produce smaller molecules. Covalent bonds are broken. Anabolism is building up, restoring, right? Restoring is more endogenic. So anabolic reactions are endogonic, all right? Endogonic. Why catabolic reaction is hexagonic? It gives out energy, all right? So that leads us to redox. First of all, let's break it down. Redox reaction, that's reduction and oxidation. What is reduction? Reduction is any chemical reaction in which molecules gain electron. It gains electron and energy. And during reduction, if it gains electron, what does it mean? It means that it is reduced. Remember, electron is negative. It's just like you getting debt. It's just like you getting married to someone and the person has debt. So if you have $100,000 in your account and the person has debt of $50,000, automatically both of you now have $50,000. So reduction reaction are gaining electrons. Again, electrons is negative, so you automatically become reduced. So molecules is reduced because they accepted what? Electron. And the molecules that gives out an electron is called what? Reducing agents. I am giving you a debt, so I am an agent that reduces what? That is reducing your financial your net worth, because I'm giving you a debt. So I become what? A reducing agent. So I need you to understand reducing agents when we say something is reduced. Extremely important. When we are talking about oxidation, it's opposite of reduction, all right? Just accepting of electron. Oh, take this debt. I accept this debt. That's what oxidation is about. And anybody that is accepting is known as what? An oxidizing agent. So oxidation is a chemical reaction in which a molecule gives out up electron and releases what? Energy. Now, when these two things are happening at the same time, it's known as what? Redox reaction. You see? It's known as what? Redox reaction. All right? Okay. And also the mnemonic oil rig helps a lot of people. What is oil rig? OIL. Oxidation involves loss. Oxidation involves loss. Loss of what? Electrons. That's O. Oxidation. I involves L. Loss. Then rig. R. Reduction. I involves G. Gain. So if you just put it to your head, oil rig. Oxidation involves loss. Rig. Reduction involves gain. You are good to go. You are good to go. That's the worst they can ask you in any exam. So this is what I was mentioning about catabolic and anabolic reaction. All right. Catabolic is breaking down, right? It releases energy, so it's known as hexagonic, in case of if you're asked, all right? So catabolic like demolition, breaking down, you understand? That's catabolic reaction. Anabolic is the opposite. So this is the metabolism I discussed initially. Metabolism, all reaction, chemical reactions, catabolism, and anabolism. Also, I need you to understand what decomposition is and synthesis is. Decomposition is more like breaking down complex carbohydrates into simple what? Sugars. Complex carbohydrates into simple what? Sugars. You need to know what is being broken to what. Like, for example, starch is broken to glucose. Protein is broken to amino acids. Fat is broken to fatty acids and what? Glycerol. It's more like dismantling a molecular logo castle into an individual block, right? Breaking everything down. So complex starches are broken down. Enzymes act as molecular scissors, cutting it up. Individual glucose units are released. Body can now use this simple glucose. Extremely important for you to know. You understand? Why synthesis is what? Building up. Decomposition is what? Breaking down. Very easy to remember. And as we're on this, you need to know starch, for example, breaks down into oligosaccharides, right? Because it's a polysaccharide, breaks down into oligosaccharide. That's 8 sugars combined together by peptide bond. So, they can now break it down more to disaccharides. What are examples of disaccharides and what example of monosaccharides? That's what you ought to also remember in terms of decomposition. So like disaccharides, you have something like, maltase, you have something like sucrose, we have something like lactose. These are disaccharides. So maltase is broken down into 2 glucose units, monosaccharide. Lactose is broken into galactose and glucose, meaning that galactose and glucose are what? 2 monosaccharides. And sucrose is broken down to what? Fructose and glucose. So in the equation, they can tell you one of the following is not an example of monosaccharide, or one of the following is not an example of disaccharides. So you need to know the disaccharides and what they break down into. And you need to know the polysaccharides, like starch, like protein, like fats. Extremely important for you to know. This is how you'll be able to understand decomposition properly. Moreover, you need to learn the functional groups. Learn functional groups. Carboxyl, methyl, hydroxyl, phosphate. You need to learn them. So that when they ask you which one is not a functional group, you will be able to know. Or when they ask you which of the functional groups contains nitrogen. For example, if I give you these examples and tell you Which of the functional groups contains nitrogen? Will you be able to know that ammonia is NH2 and it contains 2 nitrogen and 2 hydrogen? Will you be able to know that? This is phosphate. This is hydroxy. Hydroxy, for example, is OH. Methyl, for example, is CH2. CH3 rather. Carboxyl is COOH. Meaning that you need to know the functional groups because they can bring a lot of questions from this. I just gave you one. Also, they will ask you the difference between an organic molecule and inorganic molecule. I just brought it out here for you. An organic molecule is a molecule that its compounds contain what? A carbon to hydrogen bond. There must be a carbon to hydrogen bond. If there is no carbon to hydrogen bond, it is not what? Organic. It's what? Inorganic. Example is CO2. For example, some people feel that organic is the only anything that contains carbon. But CO2 is not organic, it's inorganic. So inorganic is when they contain what? Carbon to any other thing, but not carbon to hydrogen. So they are more like membership cards for the organic chemistry club. All right? Your membership card is what? Carbon, hydrogen, bond. Chicken. Also, I want you to know about demolition of polymers, right? So breaking down of polymers, which we talked about decomposition. Well, how do we do it? Hydrolysis reaction. If I pour water to a polymer, it will break down. All right? Chains are cut. You cut chain into what? Monomers. So hydrolysis literally means what? Water breaking. All right? So water molecules are inserted, they insert themselves at the connection points, thereby breaking the bonds that holds a monomer together in a polymer chain. So that is hydrolysis. An opposite of hydrolysis is what? Dehydration, synthesis. So dehydration helps to build back. If I remove the water, they will just join. Simple. So I want you to answer some of the questions, right? Just few questions because I've already treated a lot of the questions during the course of the discourse, right? For example, if I ask you the chemical properties of an atom are determined by what? You should be able to tell me its electron. You should be able to tell me its electron. There are other ways they can ask this question. This particular question I gave you now, they can ask it another way. They can tell you the bonding properties of an atom are determined by its dash. Electron, the same thing, the same question, the same answer, different format. I can ask you when table salt, that sodium chloride is placed in water, what happens to it? What happens to table salt when it's placed in water? The ionic bonds between the sodium and the chlorine are what? Broken. It's simple. Anytime you put something in water, that's hydrolysis. All right? And what does hydrolysis do? It breaks. Simple. They can give you a lot of options. They can tell you sodium chloride forms ionic bonds, sodium chloride form polar. Immediately you see form, that answer is wrong as far as we are putting it inside water. But when they're talking about dehydration, that's removal of water. What are you looking for? Forming, because it becomes anabolic. What if you are asked the sodium with atomic number 11 reacts with chlorine with atomic number 17 to become stable? In the reaction, sodium will what? And white chlorine will what? It's as simple as that. I mentioned it initially. Sodium will what? Give up one electron, and chlorine will do what? Accept one electron. It's as simple as that. It's as simple as that. Because sodium has 11, so 10 we make it what? We make it stable. So it can just easily throw away one. That's why it gives it up one. But chlorine has 7. It needs 1 to complete that outermost shell. It can't throw away 7 when you can easily get 1. So what does it do? Sodium, please, can you give me 1? It takes 1 from sodium, right? And the two of them become stable. What if I ask you about, as I said, sodium has an atomic number of 11 and an atomic mass of 23. That's what I just solved here. It means it has 12 neutrons and 11 protons. It's as simple as that. Atomic mass of 23. Atomic mass 23 means proton is plus neutron, and proton is 11. So if I put 11 here, I move it opposite to this side. All right, it becomes neutron equals to 23 minus, because when you move over here, it becomes a negative. Because 23 minus 11 giving you 12. So 12 neutrons and what? 11 protons. You need to open your eyes because it will tell you 12 protons, 11 neutrons. And you will just get confused. Don't get confused. You need to remember atomic number and mass number. So if I ask you about the valence electron of oxygen, you should be able to tell me 6. I've already told you about valence electron. If I tell you valence electron of chlorine, you should be able to tell me 7. Of course, because you should know how to get valence electron. All right? Remember the innermost shell is 2. Then the next one is 8. The next one is 8. The last one is also 2. So 2, 8, 8, 2. All right? So anyone that doesn't, if you put, like for example, using oxygen that is 8, I put 2 here. What is the remaining? 6. 1, 2, 3, 4, 5, 6. All right? So 6 plus 2 is 8. It's complete. So despite the fact that oxygen is not complete, like the outermost shell is not complete, because the outermost shell is supposed to be 8. But for oxygen, the outermost shell is what? 6. That's the valence electron. You can't fail this. Now, if you are asked a question like oxygen has an atomic number of 8, when 2 oxygen atoms come together, they form dash bond. What will you say? What will be the answer? When 2 oxygen atoms come together, what will it be? It will be what? a non-polar covalent, like O2. You understand? Look at this. If you look at the diagram, you see they become covalent because the two of them are sharing one. This is oxygen, for example, sharing with hydrogen, for example. So this time around, it's not O2. This is OH2. So this share with this share with this. So oxygen sharing with this is they are sharing. So they are what? Covalent. And they are sharing equally. So they are what? Non-polar what? Covalent bond. Extremely important. Okay. So because I can ask you, or you can be asked, oxygen, when oxygen shares with an oxygen, or when oxygen shares with hydrogen, but the same oxygen molecule, it becomes what? Non-polar covalent. But when oxygen reacts with hydrogen of another molecule, it becomes what? It becomes what? Hydrogen bond. Did I tell you about isotopes? Yes, I did. I mentioned isotopes. I told you isotopes is very, very important for you to know. It's when there is same elements have different mass numbers, like siblings who share the same family, but they are different. So what do they have in common? That's what you should know. Same proton, different neutron. Same proton, different neutron. So meaning that they have same atomic number, different mass number. That is isotope. So if I ask you a question that differs from one another in their number of neutrons and atomic mass, you should not tell me isomers. You should tell me what? Isotope. When you are talking about isomers, you are talking about structural formula and what? Molecular formula. The same molecular formula, but different structural formula. Molecular formula is, their individual constituents. Structural formula is their arrangements. I gave you an example, ethanol and ethyl ether. CH2, C2H6. Oh, extremely important for you to know. Now, if I give you this kind of diagram in exam, let me see this diagram, or I ask you a question on this diagram. Okay, let me give you this question. When jumping into water, you notice resistance. That resistance is caused by water's what? Is it adhesiveness or cohesiveness? Somebody will pick hydrophobic tension or hydrophilic tension or osmotic equilibrium. The answer is cohesiveness. Cohesiveness. Cohesiveness is that tension that's formed by, water molecule with each other. But when you are talking about water molecule with a surface, you are talking about what? Adhesion. But this is cohesiveness, what they have among each other. All right. Did you remember what I said about fats? How about if I ask you a question? I give you a lot of things and I tell you which one is hydrophobic. For example, I give you glucose, potassium, chlorine, water, and fat. I say which one is hydrophobic? Which one will you choose? Glucose is hydrophilic. It can mix with water. Potassium is hydrophilic. It can mix with water. Chlorine is hydrophilic. Water itself is hydrophilic. All right. So the odd man out should be what? Fat. Because what I told you, fat does not like water. They are phobic to water. They hate water. They are afraid of water. All right. So they can form hydrogen bonds with water. Extremely important for you to know this. And are you able to describe the different solutions I mentioned? I talked about a solution. I talked about colloid. I talked about suspension. Do you still remember the differences? If, for example, I tell you blood contains sodium chloride, protein, and cells, the sodium chloride is a what? You see, this is a big question. Sodium chloride is a solution. I mentioned characteristics of solution. Light passes through it very, very well. The particles is less than 1 nanometer. You see? Now, the next one, the protein is what? Colloid. Colloid. What is colloid? They are mixed. They are mixed even when standing. And they are between 1 to 100 nanometer. And light cannot pass through. And the cells are what? Suspension. So you need to know solution, colloid, and suspension. All right? Even emulsion. Emulsion is when one solution is mixed with another. Or one suspension rather is mixed with another. It becomes what? Like breast milk in fat. It becomes emulsion. So you need to know these differences. So what if you ask question on molarity or molality? Do you know the difference between rity and lity? So for example, I ask you a question, which of these is the most appropriate to express the number of molecules per volume? Volume, it should tick in your head. Anything volume should be what? R. Rity. Molarity. But if I say per weight, it becomes molality. That's what I explained initially. You can be given a question on this. You need to know what pH is. pH is the amount of hydrogen, a certain substance contains or a solution contains. All right. So the more hydrogen you have, the more acidic your body is. The less hydrogen, the less acidic. So if I tell you, for example, about lemon juice, red wine, tomato, saliva, household, which one is most acidic? I'll give you the number, all right? You tell me lemon juice, because lemon juice is 2.3. Extremely important. So the question can be, which of these has the highest hydrogen concentration? Then they will give you red wine, 3.2, tomato, 4.7, saliva, 6.6, lemon juice, 2.3. You should know that the one that has higher hydrogen will have lesser what? pH. Check it out, and you're good to go. Please take time to make comment on this video, all right? Take time to make comment. Tell me something. That brings us to Bufa again. If you ask a question like in a workout, all of you do workouts. In a workout, your muscle cells produce a lactate, that's lactic acid. Yet you maintain a constant blood pH. Why? Buffer, chemical buffers. Simple. Simple. As I explained initially, buffers does what? They mop up hydrogen or they give hydrogen, depending on if the cell is acidic or basic. But all these things that they are doing is to maintain what? Maintain, the pH. They don't want changes. They resist changes. They are phobic to changes, all right? And that's why you are alive. Because if not, exercise will be a life-threatening situation. So a solution that results in a change in pH when an acid or a base is added to it is known as what? Buffer. So that question can come in any way, all right? It can come in any way. So as I mentioned initially, buffers, the buffer, they absorb extra hydrogen. When there is excess acid, they absorb extra OH when there is excess base. Everything is for stability purposes. Now, if there's a question like a chemical reaction that removes electron from an atom is called dash reaction. What is it? I described oxidation and I described reduction. What did I say about reduction? I said reduction reaction is when one element is given to another element. All right? So if you look at this this diagram, this is a reduction reaction. So B at the end of the day, receives. All right? Very important. And it becomes negative. So it's like you giving an electron. So this A, is the one that gave to B. So A becomes plus. All right? A loses electron. It becomes plus. B gains and it becomes negative. So which one is oxidation? Oxidation is that loss. Reduction is that gain. Simple. So reduction, that gain leads to negative. While oxidation, that's a loss, leads to what? Positive. Simple. Oil rig. Remember that. Now you can be asked about hexagonic reaction and endagonic reaction. All right? And I told you that breaking down is catabolism. Right? That's catabolic reaction. So breaking down is hexagonic, releasing energy. All right? But building up is what? Anabolic, which is what? Endagonic. Sorry. Endagonic. All right? So they can ask you about potential energy. As I mentioned initially, potential energy stored in bonds is released as dash energy. That's chemical energy. Very important. And they can ask you that the breakdown of glucose to yield carbon dioxide, oxygen, and ATP can be described as what? Breakdown catabolism. Simple. Breakdown catabolism. Hexagonic. All right? This is anabolism endagonic. No, this is build up. All right? This is anabolic hexagonic. This is build up and what? Breakdown. This is catabolic endagonic. This is breakdown and build up. Well, what we are looking for is what? Breakdown and breakdown. That's catabolic hexagonic. Also, I need to mention about rate of reaction. Rate of reaction. What are the things that can increase or decrease the rate of reaction? I didn't mention this initially. Things that they can tell you which of the following would not increase the rate of reaction. Let's know what will increase rate of reaction so that when you see what will not, you can identify it. Catalyst, enzyme, temperature, concentration, all these things can increase rate of reaction. All right? But when you decrease the reactant or decrease enzyme or decrease catalyst, all of them will reduce. So we are talking about increasing the rate of reaction. All right? What is metabolism? I mentioned initially that metabolism is all chemical reactions in living organism. All. So if they ask you which one encompasses all, it's metabolism. Catabolism, breakdown, anabolism, build up. But if they ask you a question, which of the following terms encompasses all, you don't need to think 2 times before picking metabolism. And when they ask you about the composition, you should be able to understand because I discussed the composition. That's breakdown. All right? I discussed the composition. That's breakdown. They can tell you the breakdown of starch by digestive enzymes into glucose molecule is known as what? It's the composition. And also you need to know the different types of reaction. All right? Especially the exchange reaction. They can tell you which of the following equations depicts exchange reaction. They give you different equations. You should be able to identify exchange. It's as simple as that. Exchange, like A and B plus CD. How will they exchange each other? This one will move to this place. This one will move to this. A to C, B to D. So you need to watch and understand that, oh, this is exchange. This is not decomposition. This is not breaking. This is not addition. This is exchange. You should be able to identify it. All right? Meaning that you need to know all of those reactions. Also, you need to know functional groups, as I mentioned. Functional groups are very important. You need to know which one is carboxyl, methyl, hydroxyl, and phosphates, even amino. You need to know it because they can tell you which of these functional groups contains nitrogen. You are telling them amino group contains nitrogen. Also, they can ask you which one is not an organic compound. As I mentioned in this slide, I told you about organic compounds. What are organic compounds? You should be able to identify. you look at the element or the compounds, and you identify which compound is not organic. And how do you know organic? Anyone that does not have a carbon to hydrogen bond. Remove that one as inorganic, all right? So you should be able to identify organic compounds and inorganic what? Compounds. Now, I need you to know what hydrolysis is. I describe this a lot, all right? If they tell you a equation, for example, a dash reaction breaks down a dash into the monomers, what will it be? Hydrolysis breaks down polymer. It's straightforward. Hydrolysis breaks down what? Polymer. They can ask you the formula of an amino group is dash. What is the formula of an amino group? You know it's NH2. They can also ask you what is the formula of a carbonyl group, carboxyl group rather. You should tell them COOH, hydroxyl, OH. You should be able to know these things. If they ask you disaccharide, table salt, table sugar is a disaccharide called dash, and it's made up of what? Monomers called dash. So you should be able to identify, which one is disaccharide? Remember I told you disaccharides are sucrose, maltose, and what? Sucrose, maltose, and what? Lactose. These are disaccharides. These are disaccharides. And when they are talking about table sugar, they are talking about sucrose specifically. And what does sucrose gives you? It gives you what? Glucose and what? Fructose. So table sugar is what? Sucrose, not maltose and not lactose. If you see it in the exam, you can't fail this. They can ask you which one is a disaccharide. We already discussed this. I told you disaccharides, lactose, maltose and what? Lactose, maltose, and sucrose. So you look for the one that is disaccharide in the equation. Same thing with monosaccharide. They can tell you dash is a monosaccharide, whereas dash is a polysaccharide. What are the polysaccharides? You talk about starch, you talk about glycogen, even cellulose. Also, there are questions on lipids that I didn't mention initially. They can ask you in general, dash have a 2-to-1 ratio of hydrogen to oxygen. That's carbohydrate. We'll talk about lipids in a bit. But carbohydrates has 2:1 hydrogen to oxygen. You must not forget. Carbohydrates has 2:1. And I mentioned the question about proteoglycans. What are proteoglycans? Proteoglycans are what? Carbohydrates and protein. Protein, glycans, carbohydrate. That is proteoglycans. Now, in terms of fats, they can be asking you about triglycerides. They can ask you what does it contain. It consists of 3 carbon compounds called what? Glycerol. I mentioned this. Glycerol. And what are they bounded to? They are bounded to 3 fatty acids. So triglycerides are glycerols bounded to 3 fatty acids. Glycerol bounded to 3 fatty acids are called what? Triglyceride. And when they are talking about components of cell membrane, as I discussed in Cell, if you've not studied, listened to that video, click now on that video and listen to it. Cell, all right? The major components of cells, 75% is what? Phospholipid. Lipids make up of makes about 98%. 75% is phospholipids. About 20% is cholesterol, all right? And initially we mentioned about molecules that are hydrophobic. They can ask another question, which of these molecules are hydrophobic? They give you glucose, cholesterol, amino acid, protein, and disaccharide. What will you pick? You pick cholesterol. Why I'm telling you this thing is that they may not give you this specific question, but they may give you a lot of questions surrounding it. So, but if you know it, this question as a marker, you are good to go. Now, what are the functions of protein? I'll list them out for you. 1, they catalyze metabolic reaction. 2, they give structural strength to cells and tissues. 3, they produce muscles and other forms of what? Movements. And 4, they regulate what? Transport of solutes into and out of the cell. You need to know this, all right? Do they store hereditary information? No. So you need to know what they do so that if they give you what they don't do, you'll be able to identify. Also, in terms of protein, what can break the conformational change? What can bring about conformational change in protein? Denaturation, not saturation, denaturation, and not decontamination, the contamination or deconformation. No, it is denaturation. Denaturation. So also they can ask you about substrates. Like substrates is lactose is a substrate of which enzyme? You are telling them it's lactase. All right. So lactase is the enzyme. ACE enzyme breaks down what? Lactose. Extremely important for you to know this. And all enzymes are protein. All enzymes are protein. And nucleic acids are what? Polymers as well. Just like starch, just like glycogen, just like proteins, just like fats. Nucleic acid are what? Polymers. And what do they break down into? Nucleotide. Nucleotide. This question, an atom with 12 electrons, 13 neutrons, and 11 protons is a dash. Is it anion? Is it cation? Is it free radical? What is it? I want you to make that calculation and put the answer for me in the comment section below. All right? I need you to put the answer in the comment section. Also, this question, the concentration of a solution may be expressed by all of the following except. They give you options as pH, molarity, They also give you percentage weight per volume. What is the answer? Put it in the comment section below. When we are talking about different types of energy, we have kinetic, we have potential, all right? So if they tell you the vibration of an eardrum is an example of dash energy, what is it? Is it kinetic? Is it potential? Write the answer in the comment section below. So as a final question for this review, which of the following will increase the rate of a chemical reaction? Which of the following will increase the rate of a chemical reaction? Is it an increase in the product concentration? Is it a decrease in temperature? Is it an enzyme inhibition? Is it an increase in reactant concentration? I'm not giving you the answer. I want you to put it in the comment section below. So once again, I want you to subscribe to this channel. I want you to watch this video from beginning to ending. Watch it 2-3 times before you enter the exam hall. And also, I want you to comment. If you don't know what to say, just tell me, Nchebe, thank you. Well done. That is okay for me. All right? And most importantly, I want you to like. All right? So thank you very much for watching this video from beginning to ending. As I promised you, these questions are the kind of questions that usually come out in your exam. Talk about NCLEX, talk about other sub-exams like your college exams, anatomy and physiology. And if you pay very much attention and use these questions, you'll be able to understand biochemistry properly. All right? You don't need to cram these questions. You need to use it to understand. Formulate more questions from it. All right? The more questions you formulate, the better. Pause the video and think. Pause the video and answer most of the questions before I spit them out. All right? Thank you very much once again. Have a nice day.